Assalamu alaikum everyone, you are welcome in physics sessions. Today we'll speak about the new chapter with the new lesson talking about the two-dimensional motion. In the last chapter we take the one-dimensional motion and we speak about velocity, speed and free fall. Both of them are one-dimensional motion. At the beginning, what the difference between one-dimensional motion and two-dimensional motion? Okay, when we are talking about a one-dimensional motion, in fact we are talking about a straight line, okay, toward or backward, upward or downward. All of them are just one-dimensional motion and all of them in in a straight line, okay. But two-dimensional motion will be different. Two-dimensional motion, it means it moves like that, okay, or moves like that, okay. We will explain all of these motions in this chapter, inshallah. Okay, let's talk about introduction of the let's take some introduction about vectors. At the beginning we should to understand what is the vectors and how can we deal with these vectors, because that we will talk about some information about vectors, guys. At the beginning we should understand the difference between scalar and vectors quantity. Now, what the difference between scalar and vectors? Okay, now at the beginning, scalar, to be physical quantity, has a magnitude but no direction. We have just magnitude. It will be numerical quantity. Numerical quantity, we have just numbers. We don't want any direction to explain this quantity, okay, like time, like speed, like number of your book. Okay, numbers. When we are talking about numbers, we are talking about magnitude, we are talking about a scalar quantity, okay. But in other hand, a vector, we have both of them. We have magnitude and direction. It means what? We will make this arrow is the to explain the vector quantity. Now, this length of this arrow, it will represent to magnitude, and the tip of the arrow to represent for the direction. Now, the direction to the right, and suppose that it's 10 meters. Now, the magnitude 10 and direction to the right, and like that. Okay, now that is the vectors, like velocity, like displacement, like acceleration, and we take some examples about that in the last chapter, okay. And anyways, now the vectors, the physical quantity, we have both of them, a magnitude and direction, and all of our problems come, inshallah, speak about the vectors, okay. And also, guys, to explain the vectors and the scalar, we will use some symbols technique, okay. Sometimes in this book or in another curriculums, they will use some techniques for symbols to understand the scalar and vector quantity. They will make the symbol, it will be italic, like that. When you see this italic symbol, it means scalar. But when you see this bold face, yeah, like that, it means vector. Sometimes it will make it like that and have an arrow, small arrow above of the quantity. It means also vector. Okay, now in this book he will use the symbol techniques to understand the scalar and the vector quantity. Now, scalar will be italic, and the bold face, it means vector quantity. Okay, what about the vectors on the graph? How can we understand the vector on the graph? To understand that, we should to understand the beginning resultant vector. Resultant. What is the resultant? Resultant, guys, it will be the sum of the two or more vectors on the graph. Now, as you see here in the graph, this graph here, now can you see that? Now, that is the first vector and that is the last vector, and that is the resultant, guys. That is the resultant. The resultant should to be start from the tail of the first vector to the tip of the last vector. That is the resultant, guys. Now, how can we account this vector? We have some of the methods to understand how can we account these vectors. But anyways, now you can account this vector by ruler, okay, and also we have a direction. This is the direction of this one. That is the direction, and also we will talk about the direction more. Now, that is the direction of this resultant. Okay, now the resultant should to be from the tail of the first vector to the tip of the last vector, and now the resultant represents to the sum of all vectors in the diagram. Okay, that is the resultant, guys, and we will speak about that on the problems when you answer the problems. But anyways, now the resultant, it should to be from the tail of the first vector to the tip of the last vector, okay, and the size of this resultant, it's represented to the magnitude of this resultant vector, okay. Now what about the parallel vectors with each other if we have the same starting and the same ending? Okay, now look over here, guys. As you see here, now these are two have different orders. The vector have different orders, but at the end the resultant will be the same, guys. Okay, now what does it mean? It means if the vectors will be parallel to each other and the magnitude is the same, all vectors will be the same. The vectors parallel to each other and all of them the same magnitude, all of the vectors will be the same. Look over for this question to understand more. Now when the vectors will be unchanged, the answer will be this one. Why? Because if the vectors move parallel to each other and in original direction, it will be the same, not changed. Okay, I give you another example. If we have someone start from here and moves like that, okay, and start and moves up and moves like that and ends here. Okay, now we have another one, take another path. Okay, he moves like that, okay, and moves up like that, and so over this, and here start and ends here. Okay, yeah, can you see that here? Now from the start to the end, that is the resultant, and from start to the end, that is the resultant. They are parallel to each other and approximately the same starting and the same ending. Now they are the same, and this method is called triangle method. That is called triangle methods, and we will talk about that in the problems. But anyways, now here that is they are parallel to each other and the same starting and the same ending, they will be the same, not a change. Look over here, guys. I have some notes very important. That when we put the vectors should to be in or should to be the tail tip here and the tail to the second one with the tip of the first one, and like that, and like that, and like that, and the resultant vector from here, from the tail of the first to the tip of the last. Okay, now like that, guys, that is the resultant vector. And also, guys, here the units should to be the same. All of them should to be meters. We cannot account the vectors when we have some 1 meter, some another millimeter, some another by centimeter, or some 1 meter per second, some another meter per second square. We cannot account with the different units. Should to be all of them with the same units. All of them with the same units. Okay, excellent. Okay, now let's talk more about some properties of vectors. The vectors can put in any order. Okay, for example, this one, okay, it will be, can you see that the resultant here? It will be like that. Okay, what will happen if we take this one number 1 and this number 2? What will happen if we take number 2 here and number 1 there? Look over what's happened. That is number 2 and that is number 1. Can you see that, guys? Amazing. Yeah, they are the same resultant, and they are parallel to each other, the same resultant. Now we can add the vectors in any order. And also, guys, the subtract, it means opposite direction. What does it mean? It means, for example, this one is number 1 here. Suppose that it's for 10. Suppose this one is 10 meters, for example. That is 10 meters, for example. Okay, now minus 10 meters, it means like that. We will make the different direction. Yeah, we will make the opposite direction. Minus 10, and with the same magnitude, it will be in opposite direction. Just it. Okay, and we will explain now problems to understand more. Okay, now, and also, guys, we can multiplying and divided vectors and scalar also. Okay, what does it mean? It means, for example, if we have 100 meter per second to the east, okay, divided by 10 meter per second. Okay, now equals what? Equals 10 meter per second east to the east. Can you see that, guys? Now nothing changed to the direction, okay, but just the magnitude it changed. Okay, and also guys, if we say that 100 meter per second and multiply the 10 meter per second, this one to the east, for example, okay, to the east, yeah, it equals at the end 1000, okay, meter per second to the east. Okay, can you see that? Now nothing changed, just the magnitude will change, but the direction not changed. Okay, it means what? It means vectors multiply scalar equals vector, and vectors divided by scalar equals vector also, but just the magnitude will change. Okay, that is the sum properties of vectors. Now let's go for some problems to understand more. Look over here guys. Now this is the sum vectors and we want to add each other like that. Okay, which one equals this? Now we have 1, 2, 3. Of course 1, 2, 3 equals 3, 2, 1, or 1, 3, 2. The same thing with the general math or the basic rules of math. Okay, of course this one guys. Now as you see here, as I told you before, we can put all of the vectors in any order. Okay, we can put all of the vectors in any order. Okay. Okay, let's complete. Look over here guys, we have two vectors here, d2 minus d1. Okay, now d2, that's the d2, and that is d1. Okay, now but he said that d1 it will be in opposite direction, negative d1. It means we will make d1 like that, up. Why? Because he tell you that this is negative d1. Okay, now put in d1 at the beginning and d2 after that. Okay, where the resultant, it will be like that. Can you see that? Yeah, that is the right answer. Okay, now this is the number 1, this number 2. Okay, someone else told me guys, mister, I want to put number 2 before number 1. No problem, my dear friend. Look over here, this is number 2. Okay, and that is number 1. Okay, now in different orders. Okay, now this is the resultant, that is the resultant. Can you see that guys? Yeah, the resultant, it will be the same every time. The resultant, it will be the same every time if you put in any order, because they are parallel to each other. Okay, let's move for another question. Yeah, now just I will give you some notes here. As you see here guys, yeah, d2 like d4 but twice d4, and d3 like d1 but twice of d1. Now, which one will be right for this? d1 equals d4? Of course no. Of course no. d1 not like d4. They are different direction. They are different direction. All. Okay, maybe they are the same magnitude, but they are different direction. Of course, they are not the same. d1 equals negative d4. That is the d1, and that is the d4. No, not they are not in the different directions. No, they are. It will be different. d2 equals 2 of d4 but in the opposite direction. Look over, that is the d2 and that is the d4. Two of them will make just one d2. It means d2 twice of d4 in the opposite direction. Right, yes, number C, that is the right answer. Okay, yes, that is our questions here. Okay, now look over here for this question we have. Okay, now this question speak about object moves like that for 85 meters, okay, horizontally, and moves traveling for 45 meters in angle 30 degrees on the horizontal, okay, and moves for 45 meters. As you see here, you should to draw to understand how can you get out the answer. Okay, now how much the resultant and how much of the angle or the direction. Okay, now the resultant here guys, you can count by calculator and by protractor, but of course we can't use it here on the screen, but we will try to make another methods to understand how can we get this resultant and also the angle. At the end, I hope you understand this part. If you have any question, please ask me in the comments or in WhatsApp. Thanks all for watching and see you next video inshallah. Assalamu alaikum. Goodbye.